Welcome to React State as a snapshot. So before talking about understanding state as snapshot, I'll talk about state in general. So this concept is foundational in React development, setting the stage for dynamic and interactive UIs. So unlike typical variables, React State behaves uniquely, enabling components to react and update in response to user interactions and data changes. What is state in React? So in React, state represents the component's data at a given point in time. So think about it as a snapshot of your application's UI. And this snapshot includes all the information needed to render the component. It could be user inputs or applications data and the UI control states. However, React state is not just any variable. It's managed by React in a way that when updated, it doesn't directly change. Instead, it triggers the component to re-render, reflecting the new state in the UI. And this mechanism ensures that the UI always stay in sync with the underlying data. So if you take a look at this example I have, we're going to look at this similar example over and over. You can see that we have an app component, and this app component uses a use state that is imported from React library. And then this state gets initialized to 0 and gets the value count. And then set count is the updater. And as this button gets clicked, it's going to increment count by 1. Setting state triggers re-renders. So when we update the state using the set state function or the use state hook, we're not directly modifying the state variable. Instead, we're telling React, hey React, I want to update this piece of state. Then what React does is React schedules a re-render of the component with this new state value. And this process is different from how we might intuitively think about updating variables. And it is a core part of React's design, allowing for efficient updates and rendering of the UIs based on user interactions and data changes. We'll definitely talk more about this React design in a different lecture. State updates are asynchronous. So a critical aspect of React's state management is its asynchronous nature. So when we call set state, what it does is React batches these updates for performance reasons, and this means the state does not update immediately. You might be wondering, like, why this is happening and why it matters. It's because it affects how we write logic that depends on the state being up to date. So we need to understand that the state value might not reflect our updates immediately, which is really important for handling subsequent operations that rely on the current state. So if you look at this example, we have this handle click, and this handle click calls set count, and this set count will you need to provide what the next state of the count should be, and we said that count should be count plus 1. So when we console log count, what happens is it's going to show the old count value instead of the updated one that is incremented by 1. Accessing state in event handler. So in React, event handlers capture the state as it was at the time of the component's render. This means that if you update the state within an event handler and then access it, you will get the state before the update. You saw this example. This snapshot behavior ensures consistency, and each render cycle creates a specific instance of event handlers tied to the state as it was. So this is really important because understanding this helps prevent common bugs and makes components more predictable. Here's an example of incrementing state. So let's look at this. So this is a counter component, and we have a button in our component designed to increment a counter. And we have this on-click handler increment 3 times. You seeing that set number is called 3 times, you might expect calling this multiple times in a row would increase the counter by 3. However, due to React's batching and snapshot handling, each click increases the counter by only 1. This again illustrates how React treats state update as request for a new render, using the state from the render during which the update was scheduled, not immediately applying all updates sequentially. Another example, delayed state access. So let's look at this counter with alert component, and we have this handle click, which is an on-click handler. So you're setting a state number and then using alert function to display it. If you consider this to be synchronous, so if you do this synchronously, the alert shows the old state value due to the closure capturing the state at the moment of the function's execution. So even delaying the alert with set timeout will show the old value as it was scheduled with the snapshot of the state at the time. So this again illustrates the React's model of state as a snapshot, so that asynchronous operations behave consistently with the state as it was when they were initiated. State over time and asynchronous operations. So in asynchronous operations, understanding state as a snapshot is really important. So when You initiate an action based on the current state, and then the state changes before the action completes. React ensures the action uses the state from when it started. So this prevents any timing issues and inconsistencies. So it provides a predictable foundation for our application logic. And it highlights the importance of managing state thoughtfully, especially in complex applications with numerous asynchronous tasks. So this is an example. We have message sender component, and message sender component has two states. One is recipient, another is message, and initially the recipient is set as Alice and message is set as empty. And we have this form, and in this form, we also have onSubmit, which prevent default, and we have a send message handler, and this send message handler gets fired on submit, and it will give an alert saying that the message to recipient, and then show what the content of the message. And you have this input, which allows you to update the message, and on input change, the message will be updated. And then you have an option to select recipient between Alice and Bob. So you can see that the state at the time of setting a timeout is preserved, even if the state changes before timeout completes. Here's a recap. So to wrap up, the React state is an external managed snapshot triggering re-renders upon updates. It's asynchronous with updates not immediately reflected. Each render cycle has its own snapshot of state, making our UIs dynamic yet predictable. So it is important to understand the asynchronous nature of set state. So you always want to grasp these concepts, which will enhance your ability to develop robust React applications. Thank you everyone for listening.